All right, checking levels, looking good there. On mic. Hi, welcome back. Another week. I'm Agent Ultra, and I hack on stuff in functional programming languages, mainly Haskell on this stream. And we're starting a new project. So if this is your first time tuning in, welcome. You're just in time. We're starting a fairly new project. Just started it last week. We're going to try building a multi-user dungeon server, a game server. You play with multiple people. That does basically simulates playing Dungeons and Dragons in text on a computer. So we're going to try that out and see how it goes. Have fun learning about networking in Haskell. We've done a little bit of that before on the stream. And other like application design, how we're going to simulate the system. We're going to experiment with maybe like entity component systems and with, of course, with Haskell's concurrency libraries like STM, software transactional memory, things like that. So it should be a lot of fun. So thanks for tuning in and following along. With that being said, without further ado, let's hop over the code, shall we? Okay, we got a basic kind of server going up, right? You got something we can connect to. I just want to kind of outline some of the goals and like get a feel for the requirements we're going to have. I don't want to get too carried away with this project. The goal, I think, really is to, like learn a little bit about we're gonna build a multi-user dungeon. Oh, why did our music go? Our web player is gonna have a great time tonight, is it? Okay, hang on a second. Let me fix that. Try the next one. Yeah, we'll see how that goes. Anyways, we're gonna build a multi-user dungeon. To learn about highly concurrent network programming. Have fun, of course. All right. So what are some of our requirements? I was thinking about this a little bit. I think it's often important to think about your requirements before you start like a major project. Or maybe like while you're in the middle of it. At some point in time, you got to think about it. And maybe your specifications. This isn't going to be a super serial project. It's a learning project, so we don't have to go like hardcore on this. But just want to like, requirements are like what the people using the thing involved in what the thing is trying to achieve, right? The system itself, right? So it can be very, very high level. Think like a traffic intersection, say in North America or wherever you're from, right? You have this problem where you've got roads and you've got these motorized vehicles going at fairly high speeds on the road, and you have people and that want to cross it, and people typically cross at all kinds of places, but like at this intersection it's very, very busy, so you want some kind of system that enables some of those cars to get through, some of those motorized vehicles, and some of those people to get through. And you don't want either of those things, any of those entities using that intersection to collide with each other, right? So you have those kinds of requirements for such a system. Now, the specification is like how you're going to achieve those goals, how you're going to achieve those things. And so you might say, okay, well, we're going to have like a light system that like indicates to cars when they can move, or they indicates to the vehicles when they can move. And then we have a second set of lights that indicates to pedestrians when they can move. And we'll have these painted lines that will tell everybody where they can go and that kind of things. Those would be able, kind of the specifications to the project. Okay. The player is not happy today. The music. Toot, toot, toot. Try this. There we go. Okay. Hopefully it'll be fine now. All right, so some of our requirements. Should enable clients. Should enable as many clients to connect as the OS allows. Maybe. Might be a little bit broad. We want users, people, players, be able to register an account, should be able to create a character. Should we call it a character or like an entity? Because we're gonna have like an entity component system probably in the simulation layer to like manage everything. An avatar. That's a good one. On an approved count. Maybe was able to authenticate their account against their account credentials. Players should be able to interact with the game simulation through commands, by sending commands and receiving updates in real time on the server. Pretty loosey-goosey. Should be pretty good. So we could probably get some of these things going. And that's probably enough for now. I just wanted to add a little something there just to keep us on track. Okay, cool. Let's get to some code. So our server here is in our network server, run TCP server. All right, so this is our main loop that runs the server functionality and stuff like that. That runs the server's main loop, right? So it's always listening for sockets, listening for connections, accepting the connections. Setting everything up, and then spawning a thread to run our function, our server function, which is going to be talk here. We're going to have to clean this up a little bit because this is like all fairly hard-coded down at this layer. I want to provide a little bit of separation to things now at this point. So I think what we should have on some level is, well, I want to keep the responsibilities of our system like separated cleanly into nice layers, right? And I've written about this on my blog a little bit, like designing functional applications, things like that. And God, this player is really not gonna work tonight. That's so awesome. Anyway, and so you want to keep the effect heavy stuff, like the stuff that talks to I/O, right? This guy up here. You want to keep I/O stuff at the very edges of your program as much as you can. Like force it there, so you can keep as much of your application code as just pure Haskell functions, because those are super easy to test. They're super fast to test, and it's a lot easier to reason about your program when there's like the non-IO parts are a lot easier to reason about. That is, like, you can see the logic of how everything fits together much easier in like pure types than you can in IO, because in IO things happen, right? You're talking to databases, you're talking to file descriptors, you're getting data from places outside of your process, and things crash and all kinds of stuff. And as much as possible, we want to distance ourselves from that and kind of provide a nice little layer for our stuff to talk to it, but most of our business logic to be in the pure realm. And so one way I want to disconnect this layer here a little bit, it's not going to be, this isn't going to be like a pure layer, but it's going to distance ourselves one tiny little bit from IO. Right? It's going to be like main is up here running our TCP server and stuff, and like our main loop. So when we get a socket, actually let me try it this way. All right, we get a socket connection come in, and we already kind of keep the map of all the connected sockets in some server state. This type here, server state. What I want to do is set up for each of those sockets now is instead of writing to the socket directly with send all here and all that sort of stuff, I want to provide some channels, some IO channels, like some communication channels, or talking to the servers, the system, right? And so at this layer, all we have to do is get stuff off of the data off of the socket and put it on the input queue. Check if there's anything on the output queue for that socket and send it to the socket. Right? And so we're just concerned with this little piece here at this layer. Right? Okay, so let's look at what we got. SDM has a bunch of primitives we could use here. And I think we probably want to use bounded queues. Right, we've got TBQ. Okay, it's a bounded version of a queue. The queue is a maximum capacity set when it is created. If the queue already contains the maximum number of elements, then write blocks until an element is removed from it. Okay, so using a bounded queue would let us make sure that, like, for the inputs, right, the user can only, like, if the client connected is trying to like script, say, write a script to run a bunch of the commands really quickly, right? They may end up filling up their queue, right? In which case their commands are gonna time out maybe or something like that. Probably put a timeout on it or something, or like give it a message saying like, you know, you're going too fast, like a rate limit kind of message. But that also makes sure that the client writing such a script, if we were using an unbounded queue, couldn't overload and use up all the memory on our server, or like allocate it to our process. Right? And so we could limit how many commands they can queue up. Similarly for the output as well. Um, we control that queue, so for the output queue, we might be okay doing an unbounded queue. Only because, well, we could do a bounded queue on that one as well, but if the server gets into a state where, or a client gets into a state where it's not reading off of that queue anymore and we're blocking on it, we don't want to block any updates sending out to that server. So we might need a timeout on that. We could do a timeout on that as well, like timeout their status updates, things like that until the client reconnects and gets caught back up, or we can clean it. We can clear out that connection. The client can start a new one. Or we even we could, we have that connection in state and memory. They reconnect, that kind of stuff. Anyways, we could figure that out. But yeah, maybe we should use a bounded queue for both. But like we could have an unbounded queue maybe on the memory on the server side, and we could queue up a good number of some number of things before we start. Like we could be a little bit soft about it. Maybe we could do an unbounded queue there and then a bounded queue for the input. So let's look at our connection type. Right, we have the authentication state, not the authorization state. The authentication state is just to like have you've registered, this count as this connection has tested their credentials against their account and everything's fine. Or they're still anonymous, and so they don't get access to certain commands and things like that. So in the connection, we could probably put like we could put their queues here, maybe, or at least references to them. Sheesh, the music is not happy with us tonight. Come on, pretzel. Okay, so let's try putting them here. Port control concurrent stm.tbq. I have a GHCID for this. Don't. I'm not using Nix on this project, that's right. Do I get that? HLS, stack, GHCL, Cabal. Tend to prefer GHCID. Loading my stuff. So this is going to install it in my local system, kind of globally for all my projects, but perfectly fine. At least for GHCID. Okay, so while that's running... Oh, it's already done. Okay. Okay, TBQ. Yeah, as a higher content type needs a type. What kind of things are we gonna have in it? Okay. What are we gonna have in it? Let's just start with text. Data.text. Probably need update the Cabal file. There we are. Okay, and now we're gonna lose that and server. Now we can't show that anymore. Right, and the connection needs a little bit more setup here. Okay, so let's go ahead and add that. Metaphysical hiccup. Sorry, you're getting banned. Unreported. Okay, that aside. Okay, so once we authorize here, we can create our TBQ, our bounded queues. Maximum number of levels the queue can hold, and new TBQ. We can do it in STM or in IO. We can do it in IO, so let's do that. Let's hard code it for now. And input Q, go there. Okay, cool. We're back to green. That's good. Okay, so now the connection has the input and output queues. We should be able to put something on the output queue Or get something off of the input queue, and then, like, for now, our server will just echo it back by putting it on the output queue for that socket, that connection. And that should give us, like, the kind of framework setup that we need to be able to start implementing and separating the layers here, so that we're not necessarily case matching here in this loop on what the client is exactly sending. Okay, so first things first, the message. We should receive the message, and because how are we gonna? Okay, we're gonna have to construct the input queue and the output queue. Sooner in this code. Talk here, I feel like, should only be talking to those queues. Well, talking to this socket through those queues. Yeah. So maybe we need like an initialized connection function. Does that. Okay. Basically, take all of this code. Place it with that, put that here. And then, on the loop up here, the main loop, right? We're gonna init the connection. And with the socket. Then we can talk to the server. We could even have a... Oh, no, that's good enough. We'll just init the connection. And then talk here isn't going to dispatch on commands really much at all. What are we going to do? We're going to, unless the message is null, well, I think even if the message is null, it doesn't really matter too much. Because we might have output to send. When it's not null, when there's a pattern for this. I'm not remembering what it is. So when it's not null, though, we're going to put it on the input queue, basically. The talk here shouldn't even get the socket. No, it does need the socket, but the socket comes from the connection, so it doesn't. We don't need to pass it in directly. So we're forking a thread here. It's gonna have... Yeah, maybe we don't need to put it in the connection necessarily. Because we could put it... Well, because talk is going to be such a weird function. Alright, like right now it gets a socket. What do I want? What do I want to happen here? I want to really talk to this connection, not necessarily this socket. So maybe a socket's too low level. Maybe init connection should return our connection. And we'll call it client connection. And I don't think we need the server state. All right, we have the connection. I could probably use record wildcards to pull out here all the fields. Then we need the socket in there as well. Yeah. Hmm. This callback function up here is pretty. Sorry. Okay, yeah. Okay, there we go. So then. Yeah, and then we need when. Control that monad. Okay, perfect. So when the message is not null, then we can put it on the input queue. We have... We can check if it's full before we write it. Right, or we can just write it, which will block if the queue is full. I gotta call, we need to import that. Import it here, qualified, concurrent, STM TBQ as TB. Queue is full TBQ. We can call it connection input. Redundant. Connection input. This is where we could put our like rate limiting message, I guess, or like some kind of like, please wait and try again. Otherwise, atomically. So within a transaction now, we are going to TB, oh, that has to be in a this all has to be in a transaction. So that here. Then a TB write Q. Write TBQ. Message. We'll have to bind that. Let's see, so we can recur and loop. have to bind that because it's an action. We'll call it input queue full. Yeah, we can't do IO actions inside our STM transaction. So we have to restructure this a little bit. How should we structure this? Let's say we get a message and we could try and put it on there, on the input queue, and return a result. Maybe it was a success or maybe it wasn't. We could then, if it failed, we could put a message on the output queue that it failed. Hey, Greybeard 1970, welcome to the stream. Thanks for tuning in and checking it out. Yeah, I haven't played a dedicated, I haven't dedicated myself playing MUDs. I want to say like the late aughts is probably the last time I was playing like Dragon Mud and Achia. I wonder if they're still around actually. Yep. Look at that. Iron Realm's still running them. I used to play this one a fair bit. A Dwarven Monk. It was pretty fun. And Dragon Mud. Was it called Dragon Mud or was it something else? Oh, jeez. Maybe it was Dragon Realms. Yeah, I think it was Dragon Realms. Yeah. This one was super awesome. Wow, it's still going looks like it's still going pretty strong. I gotta put one of those things on my network. Anyway, Dragon Realms. Yeah. Wow, it's changed a lot, but it looks like it's still there. Holy smokes. Yeah. Cool. So this mod I really liked because it really simulated combat in a very different way than a lot of mods for the time did. And like it simulated your stance, position, things like that. And God, it was a lot of fun. Probably maybe still is. I think this is the one. Something Dragons. I think it was Dragon Realms, yeah. Anyways. It was very cool. So that one and a Chia were our big ones. Yeah, I thought, you know, making a mud engine could be a lot of fun. Could teach us a lot of stuff about different libraries in Haskell and like concurrent networking and things like that. And it's not full scale, like a huge multiplayer MMO type of thing. Like it is the precursor to MMOs, sure, but it's implementable by a mortal soul who's just curious. Oh yeah, the old Informix games, sure. Infocom. Yeah, we did do, I did do a text adventure kind of style game in this on the stream as well in the past. I don't know if I finished that engine, but we got pretty far with it. It started off as like pure like terminal based, and then we upgraded it to be graphical, so a graphical client. And then I was starting to add like engine-ish type features, so you could like design your own games in it without having to hack Haskell. You could just input the data in it, and it would run your game. Yeah, I think we got pretty far with that. But anyway, let's get back to this here. Mm-hmm. An old database. All good, Graybeard. Yeah, it sometimes gets all jumbled up in there, you know? I've been, I think I first started programming when I was a kid back in, like, the late 80s, like 89, 88, around there. Yeah, all kinds of stuff in the old cobwebs. Oh, let's see. Okay, so the input. So when we're inside this atomically block here, we can only do STM actions. So things that change STM variables. Which is why it's complaining about this send all thing here. The send all is, excuse me, pardon me. Send all is an IO action. Okay, so let's try blocking this out, commenting it. We could do a result type, maybe, like as a return value of our transaction, if it was successful or not. Or input result. Do I want to check on this level here first if we have message? Why not? Try it out, see what happens. If not, then do do this. Wait and try again. Else, we're going to pb.write tbq connection input message, and then return nothing. There's a parse error on this because I'm a silly goose. First, atomically. No, it's not going to be quite the way to go. Oh, you know what? No, this will work. This could work. Hang on, let's uncomment this. Instead of send all, we'll just write to the output queue. If we can. Byte string, yeah. And so we need to do something with text, convert that to text. Byte string, like character encoding or text encoding. Decode UTF-8, yeah, data.text.encoding. Hey, Greybeard. It's interesting. It can be confusing, but it really depends on your experience with it. It's confusing when you're first starting out. But like most programming languages, that's pretty true for most programming languages, I would say. But once you get over the little beginning level of it, it becomes a pretty interesting way to write programs. So if you're curious and you have questions, feel free to stop me and ask. I'm happy to take diversions. And all that sort of stuff. So I'm going to import data.text.encoding. Maybe here. Qualified data text.encoding. Is text or is T? And decode UTF-8. Okay, that's not redundant yet because we still need to do the other part of this, which is where the output queue. So we could check if we have messages. 5 output messages. So we're going to atomically, we're just going to look if the TBQ for the output queue is not empty. And so we'll get is empty TBQ. And that returns a bool. Yeah. Output queue empty. There we go. So when our output queue is not empty, then we're gonna basically read off what we have to send to the client. And hopefully that won't be too fast. Like the server tick will be putting things in. Mod and chat might be putting things in. Yeah, it should be fine. So how do we drain the queue? So flush TBQ. We can officially read the entire console of the TBQ into list. Never retries. That empties it. Hopefully that empties it. Although this is going to be looping, so we can just get the next item. Right, we don't want to have to get the whole contents at once. If one of our socket threads takes a lock, well, this socket thread is only going to take locks on these queues, so it's not going to be really interfering with anybody else too much, except for the simulation trying to write to it. And like maybe the chat and stuff. Yeah, I'm just thinking like if it was like completely full, we flushed this all out, right? This would be whatever. So yeah, let's just do one. Because the loop's going to come back around, and come back around and check. So if it's not empty, let's just get one. And not wait. So if it's not empty, then we'll get the next one. And then let's do when output queue empty. Do. And then we're gonna output message. Right, that has to have an argument, of course. And this is where we can do send all, connection socket, message, output message. Yeah, we'll probably have to encode that to back to a byte string. It's probably going to be encode UTF-8. Yeah, I was right. Okay, cool. So this is our, hopefully this is going to be good enough for our input and output loop. For that connection. Right, nothing's going to be reading off the TB queue at this point, or the input queue, and like consuming our input if we connect it to this thing. So I suspect if we just run this and connect to it, it's not going to do a whole lot. So then that's where we need, we can start introducing our next layer. And that layer can feed things, can take things off of the input queue and then feed things into the output queue. All right, we might even be able to at least test that this is going to kind of work with maybe putting something on the output queue when they connect, like the server message of the day, before forking over to this. If I put something there, we're going to go TB write TBQ. And that's going to come off of the client connection. Connection output. This is just gross code. I'm not going to keep this way, but I'm just writing out to test it. Welcome to Bakamud. Connection. Okay, so now when we connect, we should still get the message of the day, but our input commands won't do anything. Let's run the server. I think we started on 3,000 or something. Yeah. Connected. Oh, when I press enter, it gets it. What if I type in stuff doesn't do anything? And supposedly that input command, that input queue is going to get full. I should. Oh, I don't even. Oh, I probably put it like 100 or something silly. I could probably make it something smaller. We could test that. There's our command queue is full. Please wait and try again. Yep, input anything else. Okay, so that kind of works-ish. At least the input queue thing kind of works, sort of. Our message of the day, I kind of expected us to get that as soon as we connected. Oh, it's because we're waiting on this receive. That's why. So this server doesn't do anything because this blocks. All right, the server won't do anything until we receive something. I wonder if there's like a non-blocking receive, or if we should have a separate thread for handling the output. That makes perfect sense why we had to press enter first. Right, because then I press enter, that means I'm sending some data from the Telnet client to the server. And we're gonna get to the server's basically the thread for our connection is basically waiting on this line right now. So I press that, then it's gonna go, okay, the output queue is not empty. Send all the message. And then loop again. So now we're waiting for input again. So I press enter. And if I press enter twice, even though there's no command, still getting there because I'm not stripping off just the empty new line. So we got some work to do still. Okay, what else do we need then to be doing here? Let's see if we can get like a non-blocking. Well, the read's always going to block. I don't think there is a non-blocking receive. Alright, yeah. So this function will block until a message arrives. A bunch of other receive implementations. Yeah, just the flags. Okay, yeah, so we're gonna need like a separate, I think probably a separate thread for input and output to the connections. This is what I'm thinking. We'll do output. All output has to do is this section here. And then loop. Then all talk has to do is wait for input and try to put it on the thing. Now we have to fork here. And make sure we gracefully close everything. If that ever fails. Or if server ever fails. If either of those threads fail, we're gonna float. We could probably even race them together. This might be good enough though. Yeah, I know I discarded it. This will make it happier. Okay. Okay, so we get Bakamud right away now. That's good. I sent 2 commands, and once I go to send the 3rd command, then it goes input queues full. Okay, cool. That's better. There we go. Cool. Ah. Yep. Oh no. There we go. Ugh, exiting Telnet is, I think, gonna give Vim a run for its money. As the most difficult program to quit. Okie dokie. So then we have our 2 threads. I think we should probably race those threads though. Do we have that in we have control lift async. Unlift IO. What are we using here? Containers, STM, base. Yeah, it's the fork finally is good enough. Okay. Let's create a little community commit. The main part of this is separating out the input and output into channels or queues, and creating 2 threads for those. So I'm going to say we're mainly modifying server here. Commit, yep. Separate add separate channels, bounded queues for client connection input and output. And add separate threads for managing the IO queues. Socket. Cool. Okay, so this should be kind of a framework now we could use to start separating out our command dispatch and business logic of all the the server stuff that we need to do. If I'm right about this architecture, that is. So So now this next layer only has to talk. It still has effects, like it's still going to be talking to and doing STM transactions, but that's it. It's not going to be doing IO stuff. Right, so it's not, as soon as it's outside of IO, we know it's not talking to databases, it's not talking to the file system, it's not, you know, that sort of stuff. Yeah. So then our command, well, this layer might still need to do a little bit of stuff to do that, to get into that layer. But hopefully this is going to be the boundary. Yeah. So next, let's do a command. And we'll reintroduce the authentication state handling stuff. So we had previously like an auth command that an unauthenticated client, when it first connects, is anonymous, and we don't know anything about them, and so they're supposed to have a very limited set of things that they can do. They can read the message of the day. Maybe we should do a message of the day command. That's what we should do. Okay, so now we need something that's going to process input off of all the queues and respond to those things. All right, so it's not going to be necessarily our sockets loop here. Well, we're going to need to start our server loop somewhere. All right, this loop here on line 35 is what checks the socket for a new socket, basically. Yeah. So running the TCP server here is run by our main. Right, we give it a function, callback function. Really, we probably don't need to give that actually as a callback function. I'm going to remove that actually, yeah. That's super necessary. I think that will work. Let me get back to GHCID. Yeah. Good commit for that as well. Remove server callback. Parameter from run TCP server. Okay. So yeah, we need to run our simulation thread now. And our simulation thread now just needs the server state. This IO here. And that's pretty much it. But it's going to fork as well. don't know what action it's going to do on the close part yet. Maybe if it crashes, it'll... Maybe we don't need fork finally. Maybe we just need fork. Because if the simulation loop crashes, we can't do anything. Oh, we should just shut everything down. Yeah, probably just return. Hey, Chiroptical, how's it going? Long time no see. Great to have you back on the stream. How were things? You do lurk occasionally? Well, that's good to know. Sometimes I feel like my ears are turning a little red. It's hard at this time, eh? Are you still running a stream? By the way, friends, Chiroptical, if you go to the link above my head, it's declarative.tv. Chiroptical helps run that site, set it up, and runs his own stream. Ah! Getting to that age where it's a little more physical now, eh? Right on. Okay, so our simulation function is going to need our server state, though. So we'll pass that in. Oh, you're streaming in the morning. Okay, cool. I'll check your schedule. Get in on some of that action. Yeah, I know how it is. It will up again. It will again one day. Trust me. When those kids, they get big real quick. Real quick. It may not seem like it when you're in it, but... Shoosh. In the rear view, you're like, holy smokes, that was fast. Okay, so now we need a function simulation TVAR. I don't want it to be an IO necessarily. But it needs to be IO on some level. What is MUD? It stands for multi-user dungeon. It's an early form of like massively multiplayer online game. But it's all text-based. So it's fairly straightforward-ish to implement a very basic server. I'm trying to go fairly basic server, but I want to experiment with some things, some ideas, so we'll see how far we take it. But the idea is like, it's like being able to play Dungeons and Dragons with your friends, just mediated by a computer. That kind of thing. So we're just getting kind of the skeleton of things going at this point right now. The main like kind of server loop and the low level stuff, that's going to run everything. And I'm just starting to get the simulation stuff set up. So the simulation's what's going to be running the world. It's going to be running the physics, running the main loop. So it's going to be a tick-based kind of thing probably. So every tick, it's going to, run all of the, dispatch all the commands that are input to it, change the server state, send it all the updates, and then next tick, and then keep going, right? Mediating this kind of virtual world that clients connect through Telnet and play with. And so we just kind of got the input-output stuff set up for the client connections. So this talk thread is the input thread. It's where we receive the commands from the user. And the output thread is listening to their output queue and giving output from the simulation and from the server to the socket. Working pretty good for that. And yeah, so now I'm just wondering if I want to run the simulation as an IO action, or if I want to do kind of like more of a MTL style monad on top of it, so I can layer out some of the other code. Let's just keep it in IO for now and refactor into that if we need it, I guess. It's probably the easiest way to start. Okay, so I'm gonna go Bakamud simulation .hs. Start a new module. We got a T-bar of the server state. And we got IO unit. This will be like our main entry point for the simulation kind of thing. We'll ignore that for now, and we'll just go what is it? Delay, sleep. No, control concurrent. Thread delay. Yeah. We got thread delay and is it T-bar? All right. Back here. No, yeah, T-bar. Okay, so we'll need that. And we'll need server state. Yeah, there we go. And I got a bit call file. Simulation. Ooh, this is going to get a circular import problem. I gotta put server state somewhere else. Let's put it Bakamud server state.hs. Grab those. Pop those. And we're going to need that. Probably both those. GHCID is going to go nuts on me because I'm changing so many things so quickly. Connection stuff. Some network. Okay, good. And then so server has to import that again. Or for the first time, maybe. And now we can import the simulation without knocking anything over with circular imports. Although I might have gotten it anyway. Oh, maybe not. Okay, good. One module. That's not right. That's better. Okay, so simulation, yeah. Okay, so this is where the meat of our stuff is going to happen now. Cool. So like the simulation is going to get the server state. So now we can run a loop here. It's going to thread delay and do nothing, but call itself again. But we can loop here. And run stuff and do stuff. And hopefully this layer, this function here is going to be the most I/O that this module will do, and then everything else in our simulation can be nice pure functions we can compose together in this part here. So this simulation layer function here just has to do the TVAR, the stuff with connections and stuff to put messages on our queue and get input messages and things like that. But it doesn't have to do anything with sockets, right? All the socket stuff is handled in the network stuff, in the network code. Net code, as we say in mud speak. All right, and then, yeah, further down the road, we're going to have, I want to be able to add scripting support to the game so that we don't, to the engine, so we don't have to, like, write the whole game in Haskell. We can write it in, like, say, Lua, and, like, the Haskell engine just takes care of, like, all this networking and concurrent, like, running the simulation and stuff like that. But, like, what to do, right? How the objects, the rooms, the entities, and stuff like that can be all scripted, hopefully, in Lua. Because there's some cool Lua bindings for Haskell that I've experimented with. Should be pretty interesting to try that out. So that'll start happening in this, maybe in this layer, maybe in another part of it, but yeah. So for now, let's get to command dispatching, at least for like hard coding some commands. So what do we need to do in the simulation? We need to get, for this tick, we need to get all the input from all the connections that we need to do. Send those off to the dispatch to dispatch to different parts of the simulation, and then collect all the updates that were done that need to be sent to the different connections. Right, in this case, we're going to do the simplest possible thing. We're just going to implement a message of the day command. Right, so you can, let's get that going. All right, let's get our input, our commands that we need to do, things we need to do from all the connections. So we have our TVAR. Let's get our server state. We got to re-TVAR. Yeah. It should just be that. How come simulation? There should be 4 modules. GC is only loading 3. What's going on? You are importing it here. If I build this, expect it's going to fail. Yeah. Oh, okay. Oh, there we go. We're missing one. That's why. Messed up. Oh, cycle. Okay. Oops. Still got the cycle in there because I forgot to remove. No, in simulation I forgot to remove that. Yeah. Beaut. Some of these warnings here. Yeah. Okay, there we go. I should be getting a warning on this module though, because we're not using state, right? Perfect. Main needs to be updated because we removed that. Okay. Better. The last commit's probably kind of worked. Get rid of that. We haven't pushed yet, so we can fix that. Good. Okay. Well, we're almost at time, but let's see if we can get that basic thing going. You know, maybe even we probably don't have time to do the command handling, but we could just like loop adding output to all the connections. So let's get that. And We have the state. The map. Map allows us... I think there's a way to iterate over all the key value pairs monadically to do actions with them. Folds. I think we could traverse. This is going to be ugly code for a sec. Need traverse and scope. What? Where the heck is my traverse? Brain. Data to foldable. Sorry, it takes our function. Oh, it takes our function first and then our traversable. Kind of want to flip that over. There we go. So for each connection, we can do an IO action now. We're just gonna put something on its output, whatever it is. We'll just put a little hello, hello, hello kind of thing. Right. TBQ. Let's go with some record wildcards here. On the connection output. And overloaded strings. Now we're good. All right, let's test out our server. Okay, it's running. I'm forgetting my hotkeys now. That's not good. There we go. Telnet. 100,000 with the server. And then we just keep getting hello like super fast. So we quit the connection. Eventually, because it's going so fast... No, wait, we're pulling that off, so yeah. That shouldn't get full. Let's up that a little bit more. Still super fast. Because I think that's like microseconds or something silly. Yeah. Anyways, that's the gist of it. Ooh. I might have gotten things mixed up a little bit in our commit history here. Let's see. Yeah, I forgot to add those. We'll stage those. Okay, with the rebase. Squish, reword that. Actually, no. I'm gonna abort this rebase. Hang on a second. What am I doing? This is STM. Change the socket stuff. Client connection. This is where we, yeah, this is where we added the threads. Okay, and that one. See, we're adding the imports here. You know what? I'm just going to squash it all down together. Add simulation. All that. Yep. Okay, that looks better. Still builds, still runs. Okay, cool. Push that up. All right. So thanks again for watching tonight. That's the end of the stream. All the code you've seen for Bakamud, the new mud server that I'm building and learning with, is available on GitHub for now. I'm Agent Ultra. I'm Agent Ultra there as well. Although, expect in the future, at some indeterminate point, I'm going to be moving all my code off, probably onto something self-hosted. But it's there for now, at Bakamud. I'll put the link in chat for you there. So have fun with that if you'd like. Give it a star. Always helps. Fork, whatever. These are the goals. We're going to build a multi-user dungeon to learn about concurrent network application development. Have fun hacking. Things like that. Experiment with some different Haskell libraries and approaches to the design of these things. And I'll see you next week. I usually do these streams now on Tuesday evenings. For a few months there, I was doing them on the Wednesdays, but now we're back on Tuesdays. So check the schedule on Twitch. Tuesday evenings at 10 after 8 in the Eastern Time Zone. You can also follow me on the socials. I'm on Mastodon, on the types.pl server, or agentultra.com. It's my website. You can get links to my YouTube channel where I back up my VOD, and links to everything else that we work on, that I work on the stream and on various things. Check out my blog posts, whatevers. Give us a like and subscribe and a comment if you're following this on YouTube, or follow me here on Twitch. Also greatly appreciated. And go to the link above my head, discord.tv. Check out Chiropticals. Cool website there where there are other streamers who are doing things in declarative programming languages like Haskell, but also Erlang, Elixir, all kinds of stuff like that. So check it out. And there's also a Discord server. I think the link is still on that site. And you can, join us on Discord as well. Oh, we got an error on the site, Chiroptical. You gotta check it out. Gotta fix it. All good. And hey, if you want to list your stream, you get down there too. So thanks again. May all your monads be free and all your types check. And hopefully we'll see you next week. Happy hacking out there. Stay safe and have fun.